In this video, we're going to learn about the cardiac cycle. So you need to be able to describe the cardiac cycle, including the main events, which are atrial systole, ventricular systole and diastole. You also need to know about the effect of pressure changes on the AV and semilunar valves. The average human heart rate at rest is around 72 beats per minute. That means that each heartbeat lasts for approximately 0.8 of a second when the heart is at rest. Each heartbeat, the heart goes through a series of events which we call the cardiac cycle. The two major phases of a single heartbeat or cardiac cycle are referred to as systole and diastole. Systole describes any time when the heart is contracting, and diastole describes any time when the heart is relaxing. Now, this diagram of the cardiac cycle shows that different parts of the heart can be in systole or diastole at different points within the cardiac cycle. So if we start off down here, phase 1, atrial and ventricular diastole. At this point, the heart is relaxed. It is filling up with blood. Blood is flowing into the left atrium and the right atrium from the veins, and blood is also pouring from the atria into the ventricles. The next phase is atrial systole. So at this point, both atria contract at the same time to force blood down into the ventricles. And that time lasts about 1/10 of a second. The third phase is ventricular systole, and at this point the ventricles contract to force blood out into the main arteries. This phase lasts about 0.3 of a second. Okay. Now, during the cardiac cycle, the heart valves open and close at different points, and we will talk more about that in a wee while. Right, let's just recap what the heart valves actually do first. So the function of the heart valves is to prevent the backflow of blood. Within the heart, there are 4 valves. There's 2 AV valves, or atrioventricular valves, found between each atrium and ventricle. And then there are 2 semilunar valves found between the right ventricle and the pulmonary artery, and the left ventricle and the aorta. So this diagram shows the positions of the heart valves. So the AV valves are there, and the semilunar valves are there and there. Again, diagram showing the position of the heart valves. Okay, the heart valves are very thin pieces of tissue. And if you haven't already, if you watch the heart dissection video, you will see what the heart valve actually looks like. Right. So let's look at what's happening in the heart in a bit more detail. When the atria contract during atrial systole, the semilunar valves are closed at this point. However, the AV valves are open to allow blood to flow into the ventricles. When the ventricles contract during ventricular systole, both AV valves will close. This prevents the blood flowing backwards up into the atria. So the only place that the blood can go is out of the heart through the 2 main arteries, and that means that the semilunar valves must be open. During diastole, the atria and the ventricles relax. Because there is now higher pressure in the arteries, the semilunar valves close, and that prevents the blood flowing back down into the ventricles. At the same time, blood is flowing from the vena cava and the pulmonary vein into the atria. The AV valves have opened again, and that allows blood to flow into the ventricles. So because of the different parts of the heart contracting and relaxing, this causes changes in pressure within the heart. And it's these pressure changes that cause the AV valves and the semilunar valves to open and close in a specific sequence. Once the atria have contracted and the blood has flowed into the ventricles, the pressure of blood in the ventricles is higher than the pressure of blood in the atria. That causes the AV valve to close. The increased pressure in the ventricles causes the semilunar valves to open and forces the blood out into the pulmonary artery. As the ventricles start to relax and the pressure in the ventricles falls again, the semilunar valves will close because there is now higher pressure in the arteries, and that could allow the blood to flow backwards. So the semilunar valves close to stop this. And then the whole cycle begins all over again. When the heart valves open and close, this causes the heart sounds which can be heard with a stethoscope. Doctors refer to these as the lub-dub sounds. The lub is when the AV valves close, that's your first heart sound, and the dub is when the semilunar valves close, that's your second heart sound. This graph shows the different pressure changes that take place in the heart, causing the opening and the closing of the valves. So if we start off on the left here, you'll see that the blue line, which is the left atrium, is above the red line, which is the left ventricle. So this means that the pressure in the left atrium is higher than the pressure in the left ventricle. So blood will be flowing from the left atrium into the left ventricle. As the left ventricle starts to contract, the pressure in the left ventricle then is higher than the pressure in the left atrium. Now that could force the blood back into the left atrium. So this pressure difference causes the AV valves to close, preventing the backflow of blood and making the first heart sound. As the pressure in the left ventricle increases, we get to a point where the pressure in the left ventricle is greater than the pressure in the aorta, represented by the black line. So that forces the semilunar valves to open and pushes blood out into the aorta. Now, as the left ventricle starts to relax, the pressure will fall until we get to a point where the pressure in the left ventricle is lower than the pressure in the aorta. Now that could cause the blood to go back into the left ventricle, so this pressure change then causes the semilunar valves to close, preventing the backflow of blood and causing our second heart sound. The pressure in the left ventricle then continues to fall during diastole until the pressure in the left ventricle falls below the pressure in the left atrium. That causes the AV valves to open and blood can then flow from the atrium to the ventricle again.